All right, let's get right into it. We're about to travel back in time. Way back. 42,000 years to be exact. We're going to uncover a story that's literally written in ancient rock and ice. And trust me, this is not just a history lesson. It's a story about a planetary-level catastrophe, and it's a chilling warning for our hyper-connected world right now.
So this really gets to the heart of what we're talking about today. Imagine this. 42,000 years ago, the invisible shield that protects all life on this planet, it just collapsed. And the scary part? The evidence is piling up that the very same thing isn't just happening again, it's actually speeding up.
I want you to really try and picture this. You're one of our early ancestors, and all of a sudden, the sky is on fire. I'm not talking about the usual northern lights at the poles. I mean everywhere. These shimmering, terrifying curtains of light are filling the heavens day and night. And this was no beautiful light show, not at all. It was a sign that our planet's defenses were down, and deadly cosmic radiation was just flooding the atmosphere. The only option? Our ancestors were forced to flee into the shelter of deep caves.
So there's a name for this event. Scientists call it the Laschamp Excursion. And you know what's truly shocking? Just how fast it all happened. The most critical part of it, which we now call the Adams event, is when our planetary shield basically collapsed to nothing. We're talking 0 to 6% of its normal strength. And the whole thing, from start to finish, it unfolded in just a few hundred years. In geological time, that is literally the blink of an eye.
Now, this massive environmental crisis, it might have actually sparked a cultural revolution. Think about it. With the shield gone, the amount of damaging UV radiation hitting the Earth just skyrocketed. And this could be the reason why, right around this exact time, we see this sudden explosion of cave art all over the globe. It wasn't just pretty pictures. It was a way to record this terrifying new world they were living in, created in the only places they were actually safe. Some scientists even have this fascinating theory that the red ochre they use so much was basically a form of primitive sunscreen.
Okay, so fast forward from ancient history to right now. Because that ancient story, well, it's starting to repeat itself. But this time, we're not digging for clues in ancient rocks. No. The evidence of our weakening shield is being tracked in real time by our most advanced satellites.
And the most glaring piece of evidence, the real red flag, is this massive region of magnetic weakness that's parked right over the South Atlantic. It's called the South Atlantic Anomaly, or SAA. The best way to think about it is like a giant dent in our planet's armor. And inside this dent, our satellites are getting blasted with intense radiation because that inner Van Allen belt dips down dangerously close to Earth's surface. Here's the real kicker, though. This anomaly isn't static. It's not just sitting there. It's growing, and it's growing fast. Get this. In the last year alone, its surface area has expanded by 8%. Let that sink in. This isn't some slow, plodding geological process anymore. This is happening on a human timescale. Our timescale.
So you gotta be asking, what on Earth is causing this? Well, the answer lies deep, deep inside the planet. We're talking about a geological anomaly of immense proportions. Picture a continent-sized blob of super hot rock, sitting right at the boundary between the core and the mantle, deep below Africa. This thing, this giant blob, it's disrupting the flow of liquid iron in the outer core. And that flow is what generates our magnetic field in the first place.
And that disturbance sets off a kind of catastrophic chain reaction. You see, this giant blob allows patches of the magnetic field with the reversed polarity to bubble up to the core surface. So now you have these reversed patches literally fighting against our main magnetic field. The result? Our main field gets weaker, and our entire magnetosphere, our shield, starts to shrink and become way less stable. It starts to shift towards this chaotic, multipolar state, kind of like the weird magnetic fields on Uranus or Neptune.
Okay, so now let's do a direct comparison. Let's put these two worlds right next to each other. The world of our ancient ancestors facing this natural disaster, and our world, facing the exact same disaster, but with this incredibly fragile technological civilization built on top.
You know, back during the Adams event, the consequences were purely environmental. Deadly for sure, but environmental. Today, the #1 threat is to our infrastructure. Our global power grid, the literal backbone of modern society, is just exquisitely vulnerable. With a weaker shield, we don't even need a massive solar storm. A moderate one could be enough to trigger an absolute catastrophe.
And we don't have to guess what that looks like. We have a terrifying real-world example. Back in 1989, a geomagnetic storm hit the Earth. In Quebec, the entire power grid didn't just flicker, it collapsed. The whole thing went down in just 92 seconds. 6 million people plunged into darkness. Just like that. And remember, that was when our magnetic field was at full strength.
So how does a solar storm actually kill a power grid? Well, the energy from the storm creates these massive rogue electrical currents. They're called geomagnetically induced currents, or GICs. These currents surge into our power lines, and they're way more than the system is built to handle. They hit the high-voltage transformers and completely overload their cores, causing them to violently overheat. The system's safety switches, of course, see this as a massive fault and do their job. They trip, and that sets off a domino effect of cascading blackouts across the whole region.
But, the crisis doesn't stop with the power grid, not by a long shot. A collapsing magnetic field would, in effect, blind us. It would erase the fundamental maps used by both the natural world and all of our own technology.
It's amazing, really. So many animals navigate using this incredible biological tool. It's basically a quantum compass. In birds, for example, there are these proteins in their eyes called cryptochromes, and it's thought that these allow them to literally see the Earth's magnetic field lines. Can you imagine? So what happens when that field becomes chaotic or just vanishes? Well, migratory birds, sea turtles, salmon, they would become completely and utterly lost, unable to find their way to breed or to feed. It would be an ecological disaster.
And make no mistake, we would be just as lost. Low Earth orbit would become a radiation minefield, just frying our satellites. We saw a preview of this with Japan's Hitomi Observatory, which was destroyed after flying through the South Atlantic Anomaly. Down on the ground, our GPS signals would get totally scrambled by a turbulent atmosphere, bringing everything from global shipping to modern farming to a screeching halt. And get this, even your basic compass would fail, because the world magnetic model it relies on would become hopelessly out of date and inaccurate. We'd have to go back to navigating by the stars.
Okay, let's bring this down to the most personal level possible. Forget about the technology. Forget about the power grid for a second. What does this do to us, to the human body?
Well, there's a direct, documented biological link. Studies have shown that during severe geomagnetic storms, the overall risk of having a stroke increases by a staggering 19%. This is not a what-if scenario. This isn't some future threat. It's a documented physiological stressor that is happening right now. And here's something that you might not expect. You think, okay, the elderly would be the most at risk, right? But the data actually shows the exact opposite. The triggering effect is greatest for people under the age of 65. It's a stark reminder that our bodies are finely tuned to this planet's environment. And when that environment becomes unstable, there are very real, very serious health consequences.
It goes even deeper. The magnetic field acts as what scientists call a Zeitgeber, which is just a fancy German word for time giver. It helps set our internal biological clocks, our circadian rhythm. So when the field starts fluctuating wildly, it can mess up our body's production of melatonin. And what does that mean? It means poor sleep, more inflammation, and a weakened immune system across the board.
So the big question is, what do we do about all this? Because this isn't a science fiction movie we can just watch from the sidelines. This is a very real-world engineering and policy challenge, and it demands an immediate, serious response from our global leaders.
And look, the path forward is actually pretty clear. There are some non-negotiable steps we have to take. First, we have to accelerate hardening our electrical grids. That means mandating devices that can block these destructive GIC currents. Second, we absolutely have to build redundancy into our navigation systems. We need to make sure critical logistics can still function if or when GPS goes down, probably by using celestial and inertial guidance systems. And third, we have to shift away from these massive, fragile, centralized power grids and move towards localized microgrids that can disconnect and save themselves, preventing a nationwide cascading collapse.
You know, the story of the Laschamp Excursion? It isn't just ancient history. It's a message from the past. It's a preview of a recurring planetary cycle that we're now entering. 42,000 years ago, our ancestors survived because they adapted. The question for us, for a complex, fragile global civilization, is whether we are capable of doing the same. The planet has sent its warning. The only question left is, are we listening?